trinomial in standard form. So that's what we're looking at right now. We're looking at standard form. Most importantly, when the leading coefficient is 1. Okay? No other number. There's no other number in front. It's just a 1. Require one method. Okay? Luckily, it's pretty much the easiest method because we're always going to end up with our variable plus or minus something, and then again plus or minus something. Okay? And how we figure out what that number is we're looking at B and C. We're trying to find two numbers that when I add them together, they give me B, but when I multiply them, they give me C. Okay? So we look for our products of our constant term, and we ask ourselves, okay, which of these product pairs add to the number that I want in the middle? Okay? And they could be positive, they could be negative. So, looking at C. We'll look at C, all right? What are my product pairs of 30? What numbers multiply to give me 30? So I've got 1 and 30. What else? 2 and 15. What else? 3 and 10. What else? 5 and 6. Anything else? Okay? And then positive and negative. Okay? Positive, negative combination. Now, this is positive and this is positive, so both of my factors are going to be positive. Okay? But as we change these to positive and negatives, then we need to be aware of, do we need positive or negatives? Okay, we're going to see those combinations. There's a pattern. Depending on the signs that you have in your quadratic, there's a pattern for what types of numbers you're going to look for. And if you can recognize that pattern, you can remember that pattern, and realize that it's there, it's going to get easier on pairs you need to use when you're doing your, okay? So it's practice, proficiency. All right? So looking at this list, what combination of numbers could I add to get 13? 3 and 10. Okay? 3 and 10, specifically a positive 3 and a positive 10, is the only combination of those numbers that gives me a positive 13 that also multiplies to give me 30. Okay? So, negative 2 and positive 15 gives me positive 13, but negative 2 times positive 15 gives me a negative 30. So I know that that's not going to work. So that's the only combination that's going to work. The signs make a big difference. All right? Now remember I said all of these factor to be the same kind of thing, right? X, all right, plus or minus something, right? That's the plus and the minus. It's a positive 3 and a positive 10, so it's x plus 3, x plus 10. It's factored. Not so bad. Yep, that's your answer. Boom. There it is. Now, if you're unsure, especially as we start to get to more complicated examples, if you're unsure whether or not you did it right, you can take your factors and just distribute and multiply and make sure you end up back here. So x times x gives me x squared. X times 10 gives me 10x. 3x plus 30. I combine my like terms. I know that it's good. So if you want to check your work, it's pretty easy to check. Multiply everything back together, and you're good to go. All right? Now, let's look at our next one. Okay? If you have your graphing calculator, go ahead and get your graphing calculator, and I want to show you a trick. All right? So, again, I want a product, if I could spell, geez Louise. A product of 24 and a sum of negative 11. So, you need to keep in mind now, since the signs are changed, in order to have a positive product and a negative sum, both numbers have to be negative. Okay? So, I'm going to show you a trick. It's pretty easy to get the factor pairs of 24, but I'm going to show you while it's easy rather than when it's harder. Okay? Your calculator will give you factor pairs if you know how to do it. you go to y equals so that you're in the graphing utility. The number that you want to get all the factors of, in this case we want our factors of 24. Okay? You can type 24 divided by x into the graphing utility. Okay? 24 divided by x. And then if you open up the table by pressing second graph, it gives you a list of the factors. Okay? Negative factors, positive factors.
How do you get x?
There's the x button. And so you can see, okay, negative 6 times negative 4 gives me 24. Negative 5 times negative 4.8. I don't want decimals because we don't use decimals when we're factoring. Negative 4 times negative 6. Negative 3 times negative 8. Negative 2 times negative 12. And so on and so forth. So that gives me all the factor pairs. And so then I just have to look at this list and say, all right, well, which ones add to give me negative 11? Negative 3, negative 8.
How do we get it to show stuff?
Second graph. And that'll show you. And you can scroll up and down through this list. You can scroll up and down through this list to see. All right, and so I can make all my factor pairs, and I can look, and I can also just remember I have 1, and I also have negative 1, and 24, and negative 24, 2, and negative 2, 12, and negative 12, 3, negative 3, 8, negative 8. All right, does that make sense? So if you're stuck on your factors, you can't find it, your graphing calculator will give you the factor pairs. Especially sometimes we'll get some bigger numbers, and listing out the factor pairs can get tedious. All right, especially tomorrow.
Can you do that one more time?
Y equals, okay, y equals 24 divided by x, second graph. It's also written up here. Okay, so I know I need negative 3 and I need negative 8. Okay, so negative 3 times negative 8 gives me a positive 24. That's what I want there. Negative 3 plus negative 8 gives me a negative 11. That's what I want there. So my factors will be x minus 3, x minus 8, because those were both negative. All right. All right. Try this one on your own. On your own, I want you to tell me what two numbers multiply to give you negative 35. So that means you have to have one positive, one negative. Add to give you negative 2. So you have to be very specific about which one is negative 2. Okay? But multiplies to give you negative 35. Adds to give you negative 2. What combination of these pairs can I use to add and get negative 2? What sign goes on which? Negative 7 and a positive 5. So negative 7 times positive 5 gives me negative 35. Negative 7 plus positive 5 gives me negative 2. So it's going to be x minus 7, because 7 was negative, x plus 5, because 5 was positive. Questions on that? All right, what are my factor pairs of 10? 1 and 10, 2 and 5, anything else? Okay. What combination could I add to get negative 6? None of them, right? I could get 11 or 9 or negative 11 or negative 9 or 7, or -7, or 3, or -3. I can't get -6. So it means I can't factor it. Does anyone remember what we call something that can't be factored?
No.
Prime. It's prime.
That's just the answer.
It's prime. It won't happen often. Occasionally. Okay. Sometimes it happens. We get something that's prime. Maybe. If there is, there won't be more than one. But there may or may not be, but there definitely won't be more than one. Because that's not fun.
Is it?
I need to make sure you can factor, not just write prime over and over and over. Alright, skip to slide 56, because I'm going to do the rest of those tomorrow. Skip to this slide here. Skip the next 3 slides till you get to this one. Alright? So, this one's a little bit more complicated looking. I have these groupings. Alright? We're going to use what's called factor by substitution. Factor by substitution. Okay? And what we're going to do is, because this is awful looking, and I don't want you to multiply and expand this and combine like terms. Don't do that. It's completely unnecessary. Because these are the same, right? Both of those groupings are identical. So what we can do is we can pretend for a minute that 4r plus 1 equals x. And I'm going to replace that expression with x. So if I replace 4r plus 1 with x, make it squared, and 4r plus 1 with x and multiply it by 8, and then I've got 16. That's a whole lot easier to factor now, isn't it? Yeah. So what multiplies to give me 16 but adds to give me 8? 4 and 4, right? So I have x plus 4, x plus 4. Now it's factored, right? Okay, so I replaced x with 4r plus, or 4r plus 1 with x. Now I'm going to go back and replace x with 4r plus 1. I'm going to take this to a highlighter, that'd be great. I'm going to take this, and we'll plug it in again back here. Now that it's factored, the hard part's done. So I can take what I substituted and I can plug it back in to my original, or into my factored expression, and now I have 4r plus 1 plus 4, and then 4r plus 1 again, plus 4. Since there's no multiplication now, I can just combine like terms. So what's 4r plus 1 plus 4? What's 4r plus 1 plus 4 simplified to? 4r plus 5. 4r 5. And I'm going to have the same thing again, right? 4r plus 5. And then how can I simplify when I have two expressions that are identical being multiplied together? I'm not going to add them. They're being multiplied. Square it. Same thing being multiplied. Multiplied by itself, it's squared. So it's 4r plus 5 squared. 4r plus 5 squared. So that's our substitution method. Okay? In a second, I'm actually going to go back a couple slides. I want to add in one other thing real quick. So you can add a note on something. Are we good here? Okay.
Should have factored the substitutions again.
2 or 3. All right. I'm gonna add a example and a half here. Okay. I'm gonna take this same expression. Okay. I'm gonna take this same expression, but I'm gonna change it to be a little bit different. 2x squared minus, go back, minus 4x minus 70. Okay. What's the difference between this one and this one? Okay, it's got a number on the far left. It's got that 2. What else? Huh? We multiplied everything by 2, right? Which means that this expression has a common factor of 2, right? So, slightly different, okay? But now, this expression, very similar to this, but with a common factor of 2. So, if you have a leading coefficient, check for our greatest common factor. In this case, our greatest common factor is 2. So we can factor out that GCF and end up with a quadratic that we can factor now. Okay? This 2 is still part of my expression, but I can factor it out first, and now I'm left with something that I can factor, as we did here, and we still end up with something similar, but just a little bit different because we had that GCF. So if you have a greatest common factor, you can factor it out first, and then keep going. Keep going if you can factor the trinomial, and that 2 is still included in part of your answer. Okay? So you get a couple of these on the homework as well, and there'll be a note that pops up. You'll see it for the first couple. It'll say, factor out your GCF first. That's what it wants you to do. Find your GCF, factor it out, then factor your quadratic again to get your final solution there. Does that make sense? Okay, you've got the rest of class time.